Hello my dear friends, welcome to IMS GATE Academy. I hope you people are doing well. You are revising your concepts. And I welcome you to the most expected concept series on the heat transfer, right? Is the audibility visibility clear? Just a minute. You can let me know if the audibility visibility is clear. Okay. So my dear friends, yesterday we started with the concepts of radiation, right? In radiation, I taught you all the basics which is required. Okay, we know that radiation networks, view factors, all those concepts are important. But before that also we need some basic concepts, and yesterday we learned the concept of what is total emissive power, total emissivity, what is spectral emissive power, then what is spectral emissivity, what is black body, now what is gray body, then what are the laws which are governing the for black body. We started with Kirchhoff's law, then we learnt the Planck's law, then we learnt about Wien's displacement law, and then finally we saw that how on integrating the Planck's law we are getting Stephen Boltzmann law, which is obviously for a black body, and for a non-black body if I have to tell, then we will multiply simply by the emissivity of that body and we get the heat radiation, the amount of heat radiated for a non-black body. Fine. We have to see what is the unit. We have to be very much careful. For example, if we are saying about the flux, then the unit will be watt per meter square. Flux is always per through the amount of energy passing through per unit area. Okay. Then energy will be always in watt only. It is not, that means joule per second. That is also fine. Okay. So yesterday we stopped at I gave you the concept of that why do we need to define the intensity of radiation. First of all, what is intensity of radiation? Why do we need to define? See, the surface which is kept on top of anything, let us say a surface is kept over here, and that surface will emit radiation. Radiation is being emitted from all the point of the surface. Now in every direction, in reality the amount of heat radiated is differing, okay, and that is why there is a need to define a particular quantity which will give you the magnitude that how much heat is being radiated in a given direction. Now direction, when I am saying, it does not come out of its own. You need to define direction in space, and for that only there is spherical coordinates. So first of all, what is intensity of radiation? What is intensity of radiation? So it is that quantity which gives you the magnitude of the radiation in a specific direction in space. For a given direction, what is the heat amount, what is the heat radiated, that is given by intensity of radiation. It is denoted by I. Now the question over here is that you need to define what is direction in space. How will you tell that this is a given direction? So for that purpose we have spherical coordinates. This also I discussed yesterday. So clearly if you see over here, this is, let us say I am talking about, just a minute, let us say I am talking about this direction I am talking about, this direction I am talking about, this direction I am talking about. So how will you tell? So that means I have to refer spherical coordinates. What is spherical coordinates? Where theta, phi and z will come. What is theta? Theta is the angle which the direction makes with the z axis. What is phi? You take the projection of this direction on the xy plane, and then the angle that it makes with the x axis is the phi. Theta is called zenith angle, phi is called the azimuthal angle. So when, first of all, why it is need to define radiation intensity? Because radiation keeps changing with direction, and that direction is represented by phi and theta. So can I say that radiation intensity differs with phi and theta? We are actually checking the variation of radiation intensity with respect to these angles. That's why I have written over here that radiation intensity is used to describe how the heat radiated varies with theta and phi. Why? Because this theta and phi itself is representing your direction. Is it clear? Okay. Now, for that, my dear friends, we need to understand the concept of solid angle. What is solid angle? Let me explain you very neatly. Okay. So first of all, I'll explain you some concept. देखो, now for example, this is a 2D body that we are talking about. ठीक है, ये 2D body है. Let's say it's a circular body. Now I want to say, I want to denote this length of the arc. I want to denote the length of the arc. So one of the best ways to denote the length of this arc is if you can tell that this arc is subtending how much angle at the center. This is one way of denoting the length of the arc. How? By telling that how much theta it is subtending at the center. Some relation is there. So let's say this is r and the arc length is x. So clearly you know that x is equal to r theta you can write, or if you want to get theta, it is x by r. Okay. So generally you know the radius of the circle, and using that I can very easily say that x is the arc length. X is the arc length, and that is equal to theta. And just imagine that it's a unit circle. Now for a unit circle, if I take, the radius will be 1, and therefore x equal to theta. Now just imagine that I am talking about the entire length of this arc. For entire circle, for the complete circle, you know that theta is equal to 2 pi radians. So I can say that x equal to 2 pi. The length of the arc is 2 pi. So very easily I am able to relate the length of the arc with respect to theta. Okay, what do I want to find? Length of the arc. How I am relating it? To theta, and this is a 2D figure. It is just a planar figure that I am showing you. Now imagine that this is not a planar figure. Actually this is a sphere. It is kind of a ball. Okay, this is not a circle, this is a ball that I am talking about, or a round cake. You can, you can assume whatever you want to say, something related to football you can say. Okay, now there I want to find out some particular portion of the entire sphere. For example, you can say, you can consider watermelon. So when a watermelon is in front of you and you have to eat, so that means you have to take out some slice. Now that is not a length. The slice is not a length in that case. It is something which is denoted by the outer area. So that outer area, if you want to denote, how will you denote? That means it must have subtended some angle. Now just try to relate with the previous case. here if I wanted to denote the length of the arc, I was saying that how much angle it is subtending at the center, and it's a very planar figure, very easy to understand. Now this is over here I am saying you that consider a 3D object, a ball, football, watermelon, anything, and that I want to take out some part from there, a slice of that I want to take out. So it is not a length, first of all, it is area. I have to talk about area. Okay. So that particular slice or that particular area must be subtending some angle at the center, and that angle itself is called as the solid angle. That angle is known as the solid angle. So similar to this angle in plane, some 3D object, what angle it will subtend at the center, that angle is known as solid angle. Now why we are studying solid angle, it will be clear in some time, but first it is very much important to understand the concept of solid angle, because questions can come from here. Okay. So let's try and understand what is the concept of solid angle. It is denoted by omega. Okay. Okay. Now imagine that in the 2D figure, I told you that if you take an unit circle, so theta will be equal to 2 pi. If you take the unit circle, so theta will be equal to 2 pi. So in this case, if you take a 3D object, if you take the 3D object, and now length I am not talking about, I am talking about the outer area, and if you take the unit circle, so omega will be equal to, what do you think, 4 pi? How omega will be equal to 4 pi? Because now I am talking about the area, and you know that the outer surface area of any sphere, if I am considering to be sphere, it is 4 pi r square, or if you are taking to be unit circle, so it is equal to 4 pi. Now how omega I have written 4 pi, that I will tell you in some time, but this is very easy to imagine. I want you to imagine first, and then I will tell you how it has come. Okay. Now my dear friends, till now it is clear that I am talking about an outer surface area, and in spherical coordinates, when I have taken an outer surface area, for example I have taken a very elemental area ds, it is very important to know what is the value of this elemental area, and the value of this elemental area is r square sin theta d theta d phi. How it has come, that also I can say, but no use right now. It is completely derivation and it's maths, no need of this. You just know that whenever I am talking about outer surface area, it is this value, it is this elemental area value that we are talking about. Okay. Now my dear friends, see one thing, just a minute. What is your ds? ds is your r square sin theta d theta and d phi. Now for example, if I integrate this entire ds, so here I have to double integrate this. Now this will give you the total surface area. Okay. So r square sin theta d theta d phi. Now theta, now this theta, see how will you get a sphere? This theta should be varied from 0 to pi, and this phi should be varied from 0 to 2 pi. Then only you will get a sphere. So theta limit should be 0 to pi, and phi limit azimuthal should be 0 to 2 pi. Then only we will get a complete sphere. So this I am integrating, so r square I can take outside, 0 to 2 pi, and then sin theta would be minus cos theta 0 to pi d phi. So minus r square I am taking out, 0 to 2 pi cos pi minus cos 0, and this is d phi, minus r square minus 1, this is d phi, this is 2r square, and 0 to 2 pi d phi, 2r square, and this is 2 pi minus 0. So we are getting 4 pi r square. So my dear friends, see how elemental surface I have taken, and if I have integrated within proper limits, so I am getting the area of the sphere. 4 pi r square is the area of the sphere. 4 pi r square is the area of the sphere. Now my dear friends, it will be very clear. See, in case of 2D object, for 2D, if I have to mention the length of the arc, I say r theta. So theta is nothing but the planar angle, and that is nothing but x by r. It is nothing but x by r. And similarly in 3D, if I have to tell x, so in place of x, now I am not referring about the length of the arc, I have to talk about area. So let's say I am talking about elemental area. Elemental area, in place of x it is elemental area divided by, what should be, now in 2D it was r, but here it will be r square, and this is equal to omega, which is equal to the solid angle. Now how is this come? I want you to match it with respect to the 2D plane. We learnt it over here, and that we are trying to project it in the 3D. Now what is omega? Omega is the solid angle. Omega is the solid angle that I am talking about. What is ds? ds is the elemental area as of now, r square. Okay. So if I have to find the formula for the solid angle, so what is ds? ds is r square sin theta d phi divided by r square. So r square got cancelled, and this is equal to sin theta d theta and d phi. This is the value, or this is the formula of the solid angle. How it has come? This I am trying to show. So if someone asks you what is the value of the solid angle, so you will simply say that it is sin theta d theta and d phi. Sin theta d theta, and it is d phi. Is it clear? Is it clear? Okay. So for example, see, now I have given you the example of a sphere. But generally in our radiation, it will be forming a hemispherical outer covering, because let's say an object is kept over here. An object, plane surface is kept over here. Now when this will emit radiation, it will be in the form of a hemisphere, hemispherical covering. So solid angle, it's very it makes common sense, it makes pretty much good sense to find the solid angle for hemisphere. So for example, I want to find solid angle for the entire hemisphere. So what I will do? Omega for hemisphere. So obviously you have to put the limits of sin theta d theta and d phi. Now theta limit, in that case I put 0 to pi. For sphere 0 to pi I put, so here I will put 0 to pi by 2, and phi will be 0 to 2 pi only. Okay. 0 to 2 pi. Now sin theta is minus cos theta, and 0 to pi by 2 d phi. 0 to 2 pi cos pi by 2 minus cos 0 d phi. 0 to 2 pi cos pi by 2, 0 minus 1 into d phi. So this is plus 0 to 2 pi into d phi, that is nothing but 2 pi minus 0, and that is nothing but 2 pi units. 2 pi units. So what is 2 pi? 2 pi is your solid angle for the complete hemisphere. Solid angle for the complete hemisphere. Now remember, in case of sphere we got this result as 4 pi. By intuition I told you that this will be 4 pi, but now we are getting for hemisphere it is 2 pi. So if someone asks you, you can get a 1 mark question also, that for hemisphere what is the value of the solid angle, and that is equal to 2 pi. What is the general formula? The general formula is this. So I hope that you are getting the value, or you are getting the meaning of solid angle. Okay, what is the formula for solid angle? How we will get solid angle? Okay. Now my dear friends, see, I have told you that if I have to write d omega, or omega also should do. So I have given you ds by r square. Actually this is the area, it is the normal area. Whenever in radiation you want to see the normal, you want to see area. See, area, say flux is going out. So always remember, flux goes out from through the surface. Through means normal. And suppose that your area is tilted by some angle theta. Your area is tilted by some angle theta in the direction of viewing. I want to see something, so it should be perpendicular, not at any angle theta tilted. So if it is tilted, so I will simply write it is actually the dn normal part by r square. So suppose some angle is given, so it will be ds cos alpha, you can say, divided by r square. So simply remember why I am writing cos alpha, because when you are seeing something, the direction is always perpendicular, not at any angle theta tilted. It might be tilted, but you have to take the vertical component. You have to take the, the projection part, the normal part, which I am saying. Once I will do the question, you will get to understand. So for example, just I am saying a very simple example. For example, given that area of the plane surface, is given as 4 centimeter square. Okay, and when it is viewed from a distance of 40 centimeter along normal to surface, so what is the solid angle? So area of the plane surface given, distance is given, so what is the solid angle? So what is the formula? Formula is dA cos alpha by r square. R is nothing but the distance. Now here very easily you put 4 centimeter square and distance is what? 40 centimeter. So 40 centimeter is pretty long distance. Now whether you consider the theta or not, it is not going to make much of a difference. So simply write 4 by 40 centimeter square, and the answer will be in terms of steradian. What is the unit of solid angle? The unit of solid angle is steradian. So I generally refer by SR. So here if you take cos, for example, I would say theta equal to 60 degrees. So if it is given, you consider cos alpha. If it is not given, you don't consider. Here I have not given. Okay. Others, whatever book you are following, please follow it sincerely. It will be sufficient. Don't refer many sources. Okay. And still, if you are struggling to understand the concepts, you can refer Sengel. Okay, so till now we are discussing what was solid angle, and now it is time to discuss the most important concept, that is the radiation intensity. Just a minute. Now what is radiation intensity? It is very important because that is the topic that we are, for what we are here today. What is radiation intensity? Now clearly I have written the definition first, that it is the rate at which radiation energy is emitted in a given direction. See, just focus on one word, at which radiation energy is emitted in a given direction. Direction is given. Now just refer over here. I want you to see over this thing. in a given direction. Okay, per unit area, that is also okay, but what is given over here? Normal to the direction. So when I am saying normal to the direction, that means any direction will be given, but you have to take the normal component. When I'll do question, it will be clear, but just try to see here, try to focus here. It is saying normal to the direction and per unit solid angle. So whatever solid angle is there, that will also be considered. Okay. Somewhere this solid angle concept is, see, solid angle concept is how the other surface is seeing the other surface. For example, two surfaces are there. So how the second surface or how this other surface is seeing the first surface, that is the concept of solid angle. How much it is seeing. And somewhere on the other, I can say that this is going to be the base when you, upon which the concept of view factor comes into picture. In the next class, when I discuss the concept of view factor and how does the view factor, reciprocity relation, all those things are coming. The basis for the view factor is nothing but the solid angle. That's why it is very important to know that what is the concept of solid angle, how it is coming. Okay. Simply remember that if two surfaces are there, how the second surface is seeing the first surface, that is given by the solid angle. But I gave you the proper example that if you take a watermelon, if you cut a slice, that how much angle it is subtending at the center, that is your solid angle. Okay. Now my dear friends, let us discuss what is the intensity of radiation. Now radiation intensity will be given by I, and I have to write here theta and phi. Why? Because it is changing with theta and phi. You know that with every theta the radiation intensity changes. Now what it is saying, it is the rate at which radiation energy. So simply write dQe, okay, radiation energy emitted. So E I have written in a given direction, normal to the direction. That means area I have to take, but I have to take the normal component. So I am writing cos theta. In the definition, why I am writing cos theta? Because he is saying the normal to the direction. So for example, it might be at any angle theta. If it is theta equal to 0, you take cos 0 1, that is fine. But if it is at any angle, let us say theta equal to 30-40 degree, you have to take cos theta. And per unit solid angle, that means d omega also you have to take. Okay. So what is the unit of heat? Watt. What is the unit of area? Meter square. And what is the unit of solid angle? It is steradian. So the complete unit for intensity of radiation is watt per meter square, steradian. I hope you remember it. Okay. Now my dear friends, see one thing. Can I write dQe divided by dA cos theta, and in place of d omega already we have seen that I can substitute sin theta d theta d phi. Sin theta d theta d phi I can very easily substitute. From where it is coming? Earlier I have discussed. This is nothing but your I, which is varying with theta and phi. Is it clear? Now my dear friends, see one thing. If I ask you what is elemental flux, what is the elemental flux? So flux is nothing but your dQe divided by dA. Okay, this is the elemental flux. So dQe by dA, if I keep it over here, so rest all the terms will go over there. Okay. So what is the flux? If I ask you what is the radiation flux, so it is nothing but dQe dot by dA, and rest I can say that this is the intensity of radiation multiplied by cos theta sin theta d theta d phi. Okay. Now my dear friends, tell me one thing. This is only for elemental area. This is only for elemental area. But in radiation I encounter with the entire hemisphere. So for the entire hemisphere, what I want to do? For the entire hemisphere, hemisphere, for entire hemisphere, I have to take the integration of dE, and that means I have to take the double integration on this part, and that will be IE theta comma phi Now for sphere I told you that hemisphere I told you that theta will vary from 0 to pi by 2 and phi will vary from 0 to 2 pi. Okay? So this is the formula for the radiation for entire hemisphere, the radiation energy, where the intensity of radiation is also there. The intensity of radiation is also there. Okay? So once again I am writing the expression. What is the total energy? See, that was for elemental energy. Why do I need to integrate it? See, this is actually, this is also giving me the flux, but this flux when I have not integrated, it is giving me for just elemental area. What is the flux? And when I have integrated for throughout the area, this is giving me for the entire hemisphere, but this is also flux. So I can say that the unit will be watt per meter square. I can say that the unit is watt per meter square. Okay. Okay, fine. Now my dear friends, again I have to write here that for what is the expression that we have learned? Theta is equal to 0 to pi by 2 and phi is equal to 0 to 2 pi. So this is I E. I am not writing theta comma phi, I am simply writing sin theta, and this is cos theta, this is d theta, and this is d phi. Now my dear friends, for diffuse surface, now see, this is for any real surface that I am talking about, and you know that IE keeps on changing for any surface. But for example, if I take the diffuse surface, for diffuse surface, what do you know? That IE will be constant. IE will be constant. You know, yesterday we have discussed that what is a black body? A black body is a diffuse surface. That means in every direction, the intensity of radiation remains the same. It will not change. That means it's a constant quantity. So I can say that IE is a constant, and simply you can simply take out IE. That means I can say that for a black body or for a diffuse surface, let me take IE is equal to B. Actually, you will get confused. I am simply writing IE for a diffuse surface. I am not bringing the black body over now. I know that black body is a diffuse, but let me say only diffuse. So I can take outside, and now it will be phi is 0 to 2 pi, theta equal to 0 to pi by 2, and that is now sin theta, cos theta, d theta, and d phi. If I have to integrate it, very easily I can write 2, and this is 1 by 2. So this is, see, you can also integrate this very easily, that is not the issue. 0 to 2 pi, this is sin 2 theta, this is d theta, d phi. So what will be the integration? This is IE which is taken out by 2, 0 to 2 pi. Now sin 2 theta minus cos 2 theta divided by 2. This is 0 to pi by 2, and this is d phi. So this is IE by 4 minus I am taking out, this is IE by 4, 0 to 2 pi, and this is, now put the limits, cos 2 theta, that means cos pi, minus cos of 0. Is it clear? ठीक है, minus IE by 4, 0 to 2 pi, cos pi is minus 1, this is d phi. So that will be minus IE by 4 minus 2, and that is 0 to 2 pi d phi. This becomes plus, this is IE by 2 and that becomes phi, that means 2 pi minus 0. So ultimately into 2 pi, so 2 gets cancelled and pi IE. Pi IE, that means my dear friends, for I can say for diffuse surface, E is equal to pi times IE for diffuse surface, and you know that IE is going to be constant, pi is also constant, so is also constant. Now very easily I can write that for black body I can write IE is equal to IB and that is equal to constant. For black body IB is constant, so E is equal to EB. Now E also I am writing EB is equal to pi times I of B. Okay, and this is nothing but flux, it is unit is watt per meter square. Okay, now my dear friends, EB value you can very easily find out by Stephen-Boltzmann law, that is nothing but sigma T to the power 4, where T is in Kelvin to the power 4, is equal to pi times IB. So if someone asks you what is the intensity of radiation for a black body, I can very easily say sigma T to the power 4 divided by pi. I can very easily say sigma T to the power 4 by pi. ठीक है, pi obviously that I am dividing it with the solid angle concept. So that means T, what will be the unit? Watt per meter square already was there, and since I have divided by solid angle, so per steradian will be the unit. Is it clear my dear friends? So yes, you have to memorize whatever results are there, that means for a black body. Now some earlier formulas were also there, so these are some of the important results you have to memorize. But I am sure that if you have understood this video, the concept of solid angle and the concept of solid angle for a black body, all those concepts are clear, I think. Okay. Okay, fine. So we started. I'll just briefly recap you what I have tried to told you. First I have explained you what is the concept of solid angle. I have taken a 2D. taken a 2D plane. Here for 2D I have explained you, and then I have explained you that when you take a 3D surface, so when you take a 3D surface, so first of all I have taken an elemental area. Elemental area is given by r square sin theta d phi. You integrate, you get this. So what is solid angle? ds by r square. ds by r square. What is the simple formula for solid angle? ds by r square. But I told you that ds is the normal area. This is the normal area. This is the normal area that I am talking about. Okay. So this is for hemisphere. I have derived it, and this is for normal area. I already have taken. If angle is there, you can write alpha, cos alpha with you can multiply. I have given a very easy example over here, and then I have explained you what is radiation intensity with proper definition, and then we have derived the expression pi times, that means flux equal to pi into IE. What is IE? IE is the intensity of radiation. IE is the intensity of radiation. So for a black body, till here we are finishing. Here we have finished, and this I hope you have got it. Now my dear friends, quickly we will see a question, so that whatever we have studied, it becomes clear. Okay, just read this question once. Just read this question. A small surface area A1 3 centimeter square emits radiation as a black body at T1 equal to 600 Kelvin. Now this is a small body. Okay, it is kept in this is the orientation that he is given. part of the radiation emitted by A1. Now A1 is emitting so much of radiation, but is all the radiation visiting A2? No, so only some part is visiting A2. So that we have to find out. Some part is reaching strikes another surface A2, 5 centimeter square area oriented as shown. Determine the solid angle subtended by A2. Now my dear friends, how much heat is, how much radiation is reaching A2, how it is going to be determined? It is going to be determined that what is the solid angle of 2 with respect to 1, how 2 is seeing the body 1, that is given by solid angle. Why is the need to discuss solid angle? Just because that how the two bodies are oriented, and that is why I told you that somewhere this forms the basis for the development of view factor that we will see in the next class. So he is asking, determine the solid angle subtended by A2 when viewed from A1 and the rate at which radiation emitted by A1 strikes A2. Okay, so all the things are there, no need to worry. Now my dear friends, I told you that in case of solid angle there is only one formula. For solid angle there is only one formula, and that you have to keep in mind. Okay, what is the solid angle formula? The solid angle formula was dA by r square. Simply I told you that it is nothing but dA by r square. Now these are very small objects, you can treat it to be a point object. So center to center distance you can very easily consider. So r equal to 75 centimeter square, that is clear, fine. What is dA? Obviously it is the area of the second surface. Why? Because he is saying subtended by A2 when viewed from A1. A2 from A2 to A1. So area of A2 you have to take. But will you take directly 5 centimeter square? That is my question. My question is, will we take directly 5 centimeter square? No, we have to check the orientation. Now my dear friends, see, here the concept of orientation will come into picture. The normal to A2 is this direction, which you can see. Let me change the pen. The normal to A2 is this direction, and it is 40 degree tilted from A1. It is 40 degree tilted. What is this line? What is this line representing? This line is representing direction of viewing. Direction of viewing. So this is the direction of viewing, and from here 40 degrees tilted. That means what is 40 degree tilted? The normal to A2. Simply remember, what is theta? I have to multiply by cos theta in the numerator. But what is theta? Theta is the angle between direction of viewing to normal and the normal to the area. Simple. Direction of viewing and normal to the area. The angle between them is theta. Simple. Clearly we can see theta equal to 40 degree over here. So what is dA? dA is 5 centimeter square into cos of 40 degree whole divided by 75 centimeter. This is 5 centimeter square. This is 75 centimeter whole square, and whatever answer you will get, it will be in steradian, and I have the answer with me, so let me write it directly. It is 6.81 into 10 to the power minus 4 steradian. Okay. So this part is done, and now we have to find out what is the radiation emitted by A1 what is the radiation emitted by A1. My dear friends, we have to take some assumptions over here. For example, I have to assume that A1 will act as a black body. What is the benefit? Benefit is that I can assume it to be a diffuse surface. Diffuse surface, that means in every direction the intensity of radiation remains constant. I can assume that. Okay. So what are the assumptions? I can write assumptions to be that A1 can be treated as black body. Simple. Over. Benefit is intensity of radiation remains constant. Okay. Why intensity of radiation is required? Because for calculating the final heat, intensity is there in the formula. So what is the intensity of radiation? I have told you already that it is E by pi. What is E? E is sigma T to the power 4 by pi. So here what temperature we will take? We will take, obviously he is stating from, he is asking that what is the area when emitted by A1. So A1 600 Kelvin is there in 600 Kelvin. So sigma is 5.67 into 10 to the power minus 8, and T1 is 600, obviously it must be in Kelvin. Okay. So 600 to the power 4 divided by pi. So this is the intensity of radiation, and if you evaluate this, you will get to be 2339 watt per meter square steradian. So this is the intensity. But why did we calculate? This was not asked actually. Why did we calculate this? Because I am going to write the formula. Now we are going to write the final. What is the energy, radiation energy leaving one and striking two? Now here we will use the formula. Now what is the formula? My dear friends, you know that it is going to be, see, check the unit, watt per meter square steradian, and I want watt, that means the energy, radiation energy leaving A1 striking A2. That means I have to multiply by solid angle, that is one thing. I have to multiply by solid angle, that is one thing. And second, I have to multiply by area. Now which area? That is the most important concept over here. Which area? Again I am asking you one thing, to notice the figure. When A1 is normal to the, what is the direction of normal to A1? Clearly you can see that this is the direction, you can see over here. What is the A1 direction? Normal direction, this is the normal direction. And what is the direction of viewing? The direction of viewing is this one, the red color, it is shown by red color. Is it in the direction of the normal, is lying in the direction of viewing? No, it is having a theta between them. So that means area, entire area I will not take, I will only take the normal area. Why normal area? Again I have to take you backwards. Why I have to take normal area? Because in the definition it is written normal to the direction I have to take. Area normal to the direction. Area normal to the, I mean normal part we have to take, and that's why we have to add the cos theta component. This concept if you have understood, then no problem will be there. So I intensity of radiation we have found out, very good. Omega from 2 to 1, this also we have found out in the beginning, no issues. Area of A1 will be there, but cos theta, but with cos theta. This thing if it is clear, then it's done. So what is I? I is nothing but, just now we have found out 2339, and that is nothing but watt per meter square steradian. What is omega? Omega is nothing but, I found out already, it is 6.81 into 10 to the power minus 4 steradian, and now only area is left. So what is A1? A1 is nothing but 3 centimeter square. So 3 into 10 to the power 4 minus 4, and that is the angle is 55 degree I think. So it is cos 55 degree. Let's check once again. Angle is 55 degree, clear. So cos 55 degree, and so that is done. This is obviously meter square, that is obviously meter square. So meter square gone, SR gone, we are left with only watt, and the answer you will get is 2.74 into 10 to the power minus 4. Or this is the answer that you will get. This is the answer that you will get. Clear? Clear? So my dear friends, this is the one example that I have told you regarding solid angle, steradian, intensity of radiation. Now why I have taken a separate class for intensity of radiation? Because this topic you might skip thinking that it is not important, but we should not be like that. We should be open, question may come from here. So this much if you have understood, it is sufficient. You at least you learn this, and you can learn your other topics, right? So today, let me tell you that today we have learned the concept of intensity of radiation, what is solid angle, what is the formula for solid angle, a question also we have discussed. And now from the next class, so 2 class I have taken for just covering the radiation basics, and from the next class we will start with the concept of view factor, and in very detail we are going to learn that topic as well. For any doubts, you can ask in the comment section, you can tag me, my name is Sourav, and if you find it useful, you can share it with your friends as well, right? So this is it for today's session. In the next session, we will meet with the further concepts of radiation, that is view factor. Now what is left in radiation? View factor, radiation networks, radiation between two surfaces, radiation shields, all those concepts we will see one by one. Okay, this is it till now. Stay safe, take care, God bless, Jai Hind.